Hello, everyone. So we'll continue with the MathCON practice test. So this is number 5 now. So we are looking for the value of this product, and then this will continue a bit more until we hit the denominator to be 71. Like, it's not obvious at first, so we do expect to get some sort of telescoping when we simplify. So let's see if we can get something like that. So the first one, 1 minus 9 over 2, that is just the negative 2 over 2, right? Negative 7 over 2. And this one will be negative 6 over 3. And then this would be 4 minus, like, this is 4 over 4. So 4 minus 9 is like negative 5 over 4. So if I want to kind of see the next one, so I will say 1 minus 9 over 5. And then this will be 5 over 5. 5 minus 9 is negative 4, so over 5. So that should be negative 4 over 5. So we do expect to see some cancellation, but so far it doesn't look like we do have. Like, I can multiply these to cancel this one, multiply this, and then multiply this. I can try such a thing, but I think there's something much better than that, because if you keep doing this, the numerator is just the value of each integer increasing by 1, and the denominator are also increasing by 1. So like the next one would be negative 3 over 6. You can confirm that by doing actual work. So 1 minus 9 over 6 this is 6 over 6. So that will be negative 3 over 6, which is what we said. And if you just continue in, you will get negative 2 over 7. But most of you already seen, I guess, something going on. If you want to continue this a few more, so you are going to hit 0 over something. So negative 1 will be next one, and then after that you will get 0. So that will be 8 and 9. So since we are going to multiply all these, the next one should be like 1 over 10, and it continue all the way to the last one. But one of the number that we multiply is 0 over 9, which is 0. Then the product itself is also 0. So that was number 5. So number 6 is a number theory. So we are looking for some of the digits of the greatest 3-digit number that has the same remainder when it's divided by 33 and 21. Like, you can list the multiple of 33 and 21s until you hit a 3-digit number, but it will be the largest 3-digit number, so which is going to take too long. So instead, we're going to find a multiple of this, and multiple of this, they will be together. They will be the same number, what I mean. So which is basically just for the least common multiple. So I'll find the LCM of 33 and 21. And I'm going to use um, the prime factorization for the LCM, which I highly recommend you to do this as well. And that was be 3 and 11 and 3 and 7. So if you are looking for a LCM, just a reminder, we are looking for a number that will be multiple of both numbers. Like, what I mean by it has to be multiple of 33, what does that tell us? It has to be multiple of 3, it has to be multiple of 11. So which means I do need at least one 3 and one 11. And it has to be multiple of 21, which means it has to be multiple of 3 and 7. So since we have 3 in both, so we are going to take that for sure, because it has to be multiple of 3 in order for it to be multiple of 33. But it has to be multiple of like 21 as well. So that is going to happen if that is multiple of 7. And if this has to be multiple of 33, it should be multiple of 11 as well. So we just take every number in the prime factorization with the highest power. In this case, it's not a big deal, but in some cases it might be. So and then multiply these numbers. So that will be 21 times 11. And you can multiply with calculators since we are allowed, but 20 times 11 is like 22, like 220. But there is another 11, so that should be one more 11, so 231. So this is the first number that is going to be multiple of 33 and 21. But we are looking for the largest number, so maybe I can include this number. Like, if I add this number to itself, I will get another number that's multiple of either given number. So like, I like to get the largest. If I multiply this by 4, or if I add this 5 times, I will get, like, if I multiply by 5, I will get something larger than 1,000, which is 4-digit. Doesn't work. So if I multiply this by 4, okay, so 231 by 4, so that should be 4. So 4 times 3 is 12. and 4 times 2 is 8, so 924. So we got the 924. If I like multiply by 5, that doesn't work because that's going to be 4-digit. So this is the number as a 3-digit multiple of these two guys. And if you want to add these two, digit 9, 1, 9, 2, and 4. So that looks like 15, choice C. But that's not the case because we do need to remember we are going to get a remainder that will be the same when you divide a 3-digit number by these numbers. So this number is the largest 3-digit number that is divisible by this, but maybe we should include some remainder. So, but what remainder should we include, right? So because we just need to get same remainder, but it doesn't matter what remainder that would be. Since we are achieving, like trying to achieve the largest number, then we need to add largest number that is a low. So what is that number? Since we are going to divide by 21, so remainder could be anything lesser than 21, not 21 or higher. So we should add 20. Let's say if we add this 20, so you will get 944. And this is the largest 3-digit number that will be giving us same remainder when we divide by 33 and 21. And you can always check that. So if you add the digits, so we are going to get 17. So this was slightly challenging, but at the same time, it wasn't too bad, in my opinion. So let's look at the next. Okay, so we have now another problem that's asking us for us to get a probability. So the table shows the number of workers, number of lamps, and defective lamps in a week. And based on this, at the end of the 5 days, a lamp is chosen at random. And what is the probability that choosing a defective lamp that is produced on Tuesday? So like Tuesday right here, and on that day, there were 800 lamps were produced, and of those, 15 is defective. So that is like the number that we look for as numerator because that's the lamp were like the produced on Tuesday and defective. So that is 15. But we like to know out of what, right? Which is the total number of lamps. So like we do have like 900 on Monday, 800 on Tuesday, 850 on Wednesday, and 750 and 700. So if I add this, I can use a calculator, which is okay. But if I add these two, that will be just average is 800. So, and that will be 1600. But also if you take 700 and 900, that's also average of 800. So that's basically, we have 5 times 800 as the total. So we can just take 5 times 800. And I just use the in a way that adding easily, but you can just use a calculator if you want to. So we are going to divide by 5. So 3 over 800 is our final answer. So I hope that was clear. So that's just the wording was a bit challenging to understand for some of us maybe, but otherwise the question itself wasn't too bad. So let's see the next one. Okay, so number 8 is a analytic geometry problem. So we have a square OABC and 1 unit is each side. So that means this is 1 unit, this is 1 unit. So we can immediately say this is 0, 1. And we are going to rotate this clockwise as given until the side B lies on the x-axis. So this guy right here is going to be BC, right? And like if you like rotate it this way, so like the point A will be touching A, and this point was B. So right here will be just B prime if I just rotate this way, and C will be right here, and then O will be at this point after rotating, so the first time. So if I rotate it, so this is the new image that I will see. But we do want BC to be lying on this side. So which means we are going to rotate this like one more time, which is nice because this point B prime will be at this same point. So this C prime will move all the way here. And this point, this was, I guess, O. So we'll be moving right here. And A will be at this point. So what we care is this BC, which is going to be the case. So after this, like 2 times facing, like touching the x-axis, the first time right here, the second time right here, then we are going to end up getting BC to be on the x-axis, okay? So which is which is good. So then we are looking for the equation of the line that passing through C and C prime. So that would be our C prime. I said this is C prime, but like I would say maybe uh, C prime prime, or I could say something else, but this is basically what we mean by the C prime based on they want it, but this could be C something, okay? So it doesn't really matter. Anyway, so the question is asking the equation of the line passing through the C and C prime. Okay, so that is the line that we are looking for the equation for, okay? So to find the equation, this is a straight line. So then we have a couple of forms that we use. Like one of them is like slope-intercept form, which is mx plus b form. And you can use some other forms as well if you feel comfortable with those. But I'll use this one in this case. But to do so, I need to know the slope, which is the m in our equation, right? So let me do that. The slope was the rise over run, or using the coordinates you can as well. But since this is 1 unit, this is 1 unit, this is 1 unit, so this is 3 comma 0, and the rise is 1 unit, and then the run is 3 units. But if I use rise over run, I need to be careful because that line goes downwards, so which means the slope is negative. But if you want to use the slope like a formula, difference of the y is over difference of the x's, you will get this immediately. But the slope is -1/3, right? So that should be right here, and plus b. Now I do have 0, 1, or 3 commas like 0 as 2 points that will be on that line, which has to satisfy the given equation. If I plug 0 for x, so this fraction will be gone, and the y value has to be 1, which means b has to be 1. So the equation that we are looking for is -1/3x plus 1 equals y. But the choices doesn't look like in this form, so let's multiply both sides by 3. So that should be 3y equals minus x plus 3. And I'll take everything on one side and 0 on the other side. If I add x to both sides, so you will get x plus 3y, or 3y plus, maybe I should that way, which doesn't matter, but so the 3y plus x, and if I subtract 3 from both sides, so I will get -3 equals 0. And that is the choice here. So it's just a straightforward question, but only thing was maybe challenging a bit, seeing that this will touch the b like x-axis after 2 times rotating on one side. So that is going to tell us this side is to be 3 units, okay? So let's look at the next problem. Okay, number 9 is a star and bars problem. So if you don't know about the star and bars, then you probably need to review that a bit because I'm not going to dive into this problem. So you can look at the description. I will add a few more question about that star and bars, so you can take a look at those for more details, okay? So we have 4 types of flavors, right? So we are given 4 options. And Albert wants to buy 11 of these, okay? And then we want to get at least 1 of each, okay? Flavors. And they could be anyway. So like if you kind of remember the star and bars approach, so it looks like this. So we do have 11 stars. They are all identical. So we have 11 stars. Okay, so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 6, 9, 11. Okay, so what we want is we want to divide the 11 stars, or 11 basically um, of those, whatever you have, into 4 groups because we want to get 4, like 1 of each at least. But when you divide this into 4 groups, I cannot do this. Like if I kind of have 3 divider like this way, so then the last type, whatever, let's say this is chocolate, we have 1, 2, 3, 4, 5, 6, and we will have, let's say, 6 chocolate and 3 glaze and 2 strawberry, but there's nothing for the last flavor, so which is why we cannot place the divider outside of the last star. So which is why we have to be careful if you need at least 1. So we can place it right here, we can place right here, we can place it right here, or we can place it like some different variation. Like I can do this as well. So that means 3, 1, 1, and what's left over. So the question just became, how many ways can I place 3 dividers into one of these spots, basically. Okay, but since we have 11 like stars, that will make 10 of these spots, and I need to choose 3 of those because I will need 3 like bars to make 4 groups, and that will happen 10 choose 3 ways. Okay, and that will give us 10 times 9 times 8 divided by 3 times 2 times 1, so that should be 3, and this is 2, and that is actually this is 4, so that will be 120. So again, if you don't know about how to manipulate this as well, that's called combination, so it's good to look at that as well, but this is just application of the star and bars approach. Okay, so let's do the last question. So number 10 is a analogy geometry as well. So area of the triangle formed by the x-axis, y-axis, and the line is given 36. So it's good to draw a coordinate plane. So let's go ahead and do that. And this is going to be our x and y axis. Okay. And we don't know the value of m, but we know the area of the triangle. If I don't want to like deal with m first, let's plug x equals 0 so we can get the y-intercept. If x is 0, so this guy will be gone, so 2y will be 6, which means y will be 3. So meaning that one of the intercept, which is our y-intercept, is 0, 3. And if I plug like y equals 0, so that should be 0 equals mx plus 6, and mx would be the negative 6, so the m, or I would say x, if I divide both sides by m, will be negative 6 over m. So then the x value would be negative 6 over m, but m could be anything. But at the end of the day, we are looking for the absolute value, which is why I will choose m to be positive or negative, which doesn't matter, up to you. But if I choose positive, then this value, x, will be negative. So I should choose something to the left of the axis. If I choose m to be negative, so that will be negative divided by negative, which is positive. So I can choose something right there. But let's say that x value will be right here. So negative 6 over m, comma 0, which we do not know the value yet. But what we know is if I connect these 2 points, that will be the triangle that we are looking for the area for, right? Because we are told the area is given 36. So if this is 3 units, and if I can find this one, that will give us the value of m easily. And if this is negative 6 over m as the value, right? So let's find that by using the area. So 3 times something, which is this leg, divided by 2 should be 36 because that's the area. And if I multiply both sides by 3, so you will get 3 times question mark, I will say that's 72 divided by 3, that will be 24. Meaning that this distance is 24 units. Or if I do the other way around, so that is the same thing. So the x value is 24. So 24 equals negative 6 over m. And I can swap this position to get m itself. So that will give us negative 6 over 24, which is just negative 1 over 4. But since we are looking for the absolute value, so we should be getting 1 over 4. Okay, so I hope that makes sense. You can just plug in numbers. Like if you couldn't come up with this idea, you can look at the choices and plug some of them and see if that actually works. And you can find the answer anyway. So that's why I would say this question wasn't too challenging because you can kind of cheat by using choice as well. Okay, so I'll see you in the next video.